Okay, and here's question 8. Given that the equation x squared plus y squared take 2px take 4py plus 3p plus 2 equals 0, given that it represents a circle, determine the range of values for p. Okay, so let's get on with it. There's the equation written out as usually, a little bit bigger here. Now what you've got to do is you've got to compare this to the general equation of a circle given in this form. X squared plus y squared plus 2gx plus 2fy plus c equals 0. Now that's straight from the formula sheet. And let's just do a little bit of comparing. 2g would have to be minus 2p. Divide by 2, so g would have to be minus p. That seems okay. 2f would have to be minus 4p. So f would be minus 2p. So the centre of the circle would be, of course, it's an equation, but it would be the negative of that, p, the negative of that, 2p. So the circle would have a centre. Okay, a thing I've ignored at the moment is c within this formula is 3p plus 2. Okay, and you go to your formula sheet and you see the formula for the radius. And it's the square root of g squared plus f squared minus c. So we've got a few negatives flying around here. Minus p squared is just p squared plus minus 2p squared is positive 4p squared minus 2p times minus 2p, giving you obviously 4p. Take away 3p, take away 2. So there we have it here. Okay, so tidying it up a little bit, you have 5p squared, take 3p, take 2, and of course the radius, would you be square rooting it? As you probably guessed, you can't square root a negative, so this is all about when is that positive, when is that greater than 0. So here we have it there. So we have an inequation. The way to do, I would do an equation, is to make it an equation. Okay, so we're going to set it equal to 0. And we're going to factorise it. Now this factorises to this here, 5p plus 2 times p take 1. Let's just check it out. 5p squared take 5p plus 2p take 3p, yeah, and plus 2 times minus 1 is minus 2. Okay, and you should be quite good at solving these by now, I would have thought. Setting this equal to 0, p would be minus 2 over 5. Setting this equal to 0, and solving, p would be 1. So if the roots of that equation are at minus 2/5 and at 1. Okay, so that equals 0 there. Now if I were to sketch a graph of y equals 5p squared take 3p take 2, of course it would have the same roots, same as the equation, and because that's positive, it would look like this. So that's a rather poor graph of 5p squared take 3p take 2, but it covers the essential features. Where is it positive? Where is it more than 0? When p is greater than 1, or when p is less than 2/5. So for that to be greater than 0, in other words, for it to represent a circle, p has to be less than negative 2/5, and p has to be greater than 1 for the circle to have a radius. Okay.